Okay, this is 1.5. This is the last lesson that we're going to do in Chapter 1. We're going to talk about compounding periods, okay, because not all periods are as simple as calculating compound interest or simple interest for 1 year. Sometimes it's a part of a year, okay? So let's do some warm-ups here. Let's try these. Now remember, when we do these, we have to do BEDMAS, brackets, exponents, division, multiplication, addition, subtraction. We have to follow the order of operations. So some might say, well, we got 3 times 4 in brackets to the exponent of 2. Some might do 3 times 4, which is 12, and square that. 12 times 12 is 144, but that would give you an incorrect answer. You have to take the 4, which is in brackets, then you have to do the exponents. You have to square that, so 4 squared, 4 times 4 is 16, and then multiply it by 3. So instead of being 144, if we do 3 times 4 squared, which is 12 squared, we do 4 squared first, which is 16, and multiply it by 3, and we get an answer of 48. Okay, so you can see order of operations is very, very important. Same with this one right here. 6 times 3.2 squared, we have to square the 3.2, take that answer, multiply it by the 6. Okay, so let's turn this on, and we've got 3.2. We can square that. I can use my up arrow 2, or I can use my square button right here. It doesn't really matter. Get an answer, and then multiply that by 6, and I get an answer of 61.44. 61.44. Okay, over here, this looks familiar. This is from the compound interest formula. Okay, so we've got 2 times 1 plus 0.5 cubed. We have to do what's in the brackets first, then put it to the exponent, and then multiply it by 2. We have to do it in the correct order, otherwise your answer is going to be wrong. Okay, so 1 plus 0.5 is 1.5. Sometimes you can do the math in your head if it's easy enough. We have to put that to the exponent of 3, so go up arrow 3, hit equals, and then I multiply it by 2 times 2 equals, I get answer 6.75. And then this one here, same thing, I have to do it in brackets, but before I add 1 to anything, I have to do order of operations. I have to do this division first inside the brackets. So I do the brackets, but then inside the brackets also has an order of operations. So I have to take 0.8 divided by 2. Okay, so let's clear that. Let's do this first. So I take 0.8, I divide that by 2, it equals, and I get 0.4. I add 1 to it, okay, and I get 1.4. That's what's in the brackets. Then I put it to the exponent of 2. So go up arrow 2, get an answer, and then I multiply it by 400. And I get an answer of 784. Okay, so it's very important that you do order of operations first within your math calculations, otherwise your answers could be wrong. Okay, so we're talking about compounding periods, and there's some things that we need to know when we're talking about compounding periods. Interest rates are usually expressed as a rate for 1 year. However, interest can be compounded in different ways. The number of compounding periods depends on the type of investment and the institution. The chart shows some compounding periods. Okay, so the word annually means interest is compounded once per year. Semi-annually means it's done 2 times per year. Quarterly, think of a $1. There's 4 quarters in a dollar. Quarterly means it's compounded 4 times per year. There's 12 months in a year, so it's done once every 3 months. Okay, that's what quarterly means, every 3 months. Then there's monthly, 12 times a year or once a month. Then there's weekly, every week. It's compounded 52 times because there's 52 weeks in a year. And then sometimes it's compounded daily. There's 365 days in a year, so it's compounded every single day. Now that's the compounding period, okay? You still have to think about years. The interest is still done in years, but the compound period might change. Now what does that mean? Well, we're going to have to get into actual questions here. Kevin wants to invest the money he earns teaching piano lessons. He found an online bank that has a high interest savings account rate of 1.8% per year, but the interest is compounded monthly. It's 1.8% per year, but they compound it monthly. So what does that mean? What is the monthly rate, and how often will his money be compounded in 5 years? So what is the monthly interest rate? Well, it's 1.8% per year. Okay, so this is 1.8 or 0.018. So that's what it is in 1 year. How many months are there in a year? There's 12. So we take 0.018 per year, that's his interest rate per year, we divide that by 12, okay? So what we end up is 0.018 divided by 12. That means he's still going to earn 1.8% a year, but they're going to divide it up over 12 months, which means that he's going to earn 0.0015% per month. Okay? They just broke it up over 12-month period. Okay? It's still 1.8% or 0.018 per year. Okay? Okay, or it's going to be 0.0015. So how many times will interest be compounded in 5 years? Okay, well, 12 years times 5 is 60 times. So the interest will be compounded 60 times. Every month, 12 months in a year, 5 years, 60 times. So that means his money is going to be calculated using this interest rate here 60 times. Okay, now what does that mean? Well, for us to figure out what that means, we actually need to do a question, okay, that involves compounding periods other than 1 year. Cheryl manages a high-rise building in Vancouver. She invested $40,000 from this year's condo fees for a reserve fund. She invested $20,000, half of it, in an account that pays 1.8% per year, compounded, here's the key, compounded semi-annually. So that means it's compounded 2 times per year. Okay? Then she took the other half, the other $20,000, in an account that pays the same interest rate, 1.8% per year, compounded daily. That means it's going to be compounded 365 times in 1 year. Now, is there a difference? Is this one going to yield more money or less money than this one? We don't know. We have to do the math. So, how does the interest earned on each investment compare after 3 years? Well, the only way we can compare them is by actually taking these numbers for each individual situation and plugging them into the interest formula, the compound interest formula. So, solution. What is the value of the investment with semi-annual compounding? Well, it's still the same formula. Amount is equal to P times 1 plus I to the n. So the first one, she invested $20,000. Okay. She did it semi-annually, which means she did it 2 times per year. So what that means is we have to take the interest rate per year, we have to cut it in half. So whatever number we have down here at the bottom, we have to put it up here with the other exponent. Okay? So we end up with $20,000 times 0.018 divided by 2 is 1.009, all to the exponent of not 3 years, but the compounding period goes up with the exponent, so it's 2 times 3 is, it's now going to be compounded 6 times, because n is the number of times it's compounded, okay? So it's compounded for 3 years, but 2 times per year, and 2 times 3 is 6. So now we just do the math. Okay, so let's move this over here. Let's turn on our calculator. Clear that. And let's do this calculation here. We have to do what's in the brackets first. So 1.009. We have to put it to the exponent of 6. Hit equals. And then we multiply that by the original principal, which is 20,000, and we get an answer of $21,104.59. Okay, so that's how much interest she has earned after 3 years at 1.8% compounded semi-annually, twice a year. The second situation, well, so this value is $21,104.59. 59. Okay. The second situation is that she took the second part of the money, the other $20,000, and she invested it at 1.8%, but she's earning compound interest daily. So let's plug in the numbers. 20,000. It's being compounded every day. How many days are in a year? Well, 365. And that means that how many times is it going to be compounded in 3 years? Well, 365 times 3. So this is 365. So now we end up with $20,000. Okay. And we have to do this calculation first. 0.018 divided by 365 and add 1 to it. If you take your calculator, we can do that here. We can take 0.018, we can divide it by 365. Okay, now that, the way my calculator shows it, it says E negative 5. That just means that it's 5 decimal places over here. It doesn't mean it's an error. And then I add 1 to it. Don't forget to add 1, and I get my actual number. And then it's going to be to the exponent of 365 times 3, which works out to 1,095. So I'll just go back to my calculator and I'll write this number in here. It's 1.00004,932. Notice how many numbers I have to carry it to? Now, I just do the math on that. So I take that number, I put it to the exponent of 1,095. It seems like it's a really big exponent, and it is, but you'll see what happens here. I get an answer, 1.055483197, and I multiply that by $20,000, and I get an answer of $21,109.78. That should be 78 cents. So the value of the investment with daily compounding interest will be $21,109.78. Now, which one was higher? When the compounding period was only 2, the amount of interest after 3 years was $1,104.59. When it was compounded daily after 3 years, 365 compounding periods, it was $1,109.78. Not a lot different, but it's still a larger number. So how does the interest earned on each investment compare? Well, we have $21,109.78. We're going to subtract the smaller one, which is $21,104.59. And that gives a difference of $5.19. So the investment that had more compounding periods earned $5.19 more in interest over the same period. So the number of compounding periods does make a difference. The higher the compounding periods, 365 compared to 2, does make a difference as to how much interest you're going to use. You're going to earn. The higher the higher the compounding periods are, the more there are, the more money you're going to make. Okay? All right, so go ahead and try some of the practice. Okay?